The inverse of resistance is conductance. So resistance is designated as R. So the conductance value is G, which is 1 over G. So basically if we have a resistance, let's say 5 ohms, the equivalent conductance can be expressed in terms of 1 over 5, and the unit is called mho, so which is 1 over 5 mho. The other unit is Siemens, so we can just write S. Now when we have two series conductance, if they were resistances, so if they were R1 and R2, we know the equivalent will be R1 plus R2. However, if they are conductances, they are expressed in terms of conductance, then the equivalent conductance will be G equivalent will be just like the parallel resistance equivalent. So basically it will be G1 times G2. So I'm just writing like that over G1 plus G2. That is the equivalent of series conductance. So let's forget these R's there, like that. And when we have two parallel conductances, they will just add up. So G1 and G2, if they are parallel, the equivalent conductance will now become just G1 plus G2. So G equivalent in this case will be G1 plus G2 when it's a parallel combination. So just the opposite of resistance. In resistance, what the formula is for series, here it's the same for parallel and so on. So now I will do a problem. Here I have to find the equivalent conductance. Here is just written what is the GEQ here, and these resistances, we can see the unit. By looking at the unit, we know that these are actually conductances. So this is 8S, 4S, 2S, 6S and 12S there. So we need to find equivalent conductance. So we will treat them as conductance and we will apply the formulas. So here this one is two parallel conductance. So the equivalent will be just addition. So if I draw it, it will be like that. And then let's draw the rest there. So this is 12S and those two were 2 and 6. So 2S, 6S, and here 8 and 4, they are parallel but conductances, so they will be just added. So it will be 12S there. So that's there. Now from this part, the lower part, we can see that these two are coming in series, and then the combination is coming in parallel with this one, these 2S. So first we find the series equivalent here. What is the series? 12 and 6. They are in series but they are conductances. So the equivalent will be 12 times 6 over 12 plus 6, which is 72 over 18, which is 4. So our equivalent circuit now will become, here we have something, here we have something. So this is 2S as it was, this is 12S as it was, this one is 4S now. This is the equivalent of this one, the series equivalent. And this is our final GEQ here, which we need to find. Now again we have 2S and 4S in parallel, two conductances in parallel, so they will be just added here. So 12S there, 2S, 4S, they are added, so that will be 6S there, sorry, 6S, like that, and we have GEQ there. Now we have finally two series conductances, and since they are conductances in series, so they will be, the equivalent will be 12 times 6 over 12 plus 6 again, which is 72 over 18, that is 4S. So our GEQ becomes, is replaced by just one conductance, which is 4S. So that's the result here.